Hi class, this is course 3, lesson 74, simplifying square roots. Here is the property, the product property of square roots that you need to know. What this says is that if you have factors under square roots, you can split them into a square root times another square root. So thinking about this, if I have the square root of 2 times the square root of 3, I could do this backwards and say that's the same thing as the square root of 2 times 3, which would be the square root of 6. Okay, now I could also break that back out to be the square root of 2 times the square root of 3. But where this really becomes handy is when you have perfect squares, because I can simplify those perfect squares. If I have the square root of 4, I know that that's 2. If I have the square root of 36, I know that that is 6. And so I can use that information to help simplify square roots. So if we look at this example here, we have the square root of 12. And what we need to find is a perfect square that is a factor. So I know that 12 would break down into like 1 and 12 as factors, or 2 and 6. But 3 and 4 is the one that I really want, because I know that 4 is a perfect square. So I'm going to rewrite the square root of 12 as a product of its factors, the square root of 3 times 4. And 4 is the one that I'm looking for, because if I rewrite this as the square root of 3 times the square root of 4, I can break this one down to just 2. So now I have the square root of 3 times 2, and I'm going to write that with this in front. So it's going to be 2 square roots of 3, and that's simplified. The square root of 12 simplified is 2 times the square root of 3. Okay, let's do a couple more examples. These are a little more difficult because I'm not sure what perfect square goes into 216. And that's okay. We can use prime factorization to help us evaluate what those factors are. So if I take 216 and let's say I know it's divisible by 4, because 16 is divisible by 4. So that would be 54. And maybe I'm going to leave 4 because I know that's a perfect square. And 54 would break down into 9 times 6. And 6 is 2 times 3. Now, I left 9 and I left 4 because I recognize that those are perfect squares, and that's what I want. However, if you broke that down into 2 and 2 and 3 and 3, that's okay, because we're just going to write this all out. I will do this two separate ways. One with all of the factors, so we have 2 times 2 times 3 times 3 times 2 times 3. And once over here where we say 4 times 9 times 2 times 3. Okay, same problem, we're just going to look at it 2 different ways. If you break the number down into all of its prime factors, then what we're looking for is pairs, because where we have pairs, one of them can come out because we can square root squares. So this is really the number 2 that will come out, and this is really the number 3 that will come out. So I will have 2 times 3 and then the square root of 2 times 3 underneath there. 2 times 3 is 6, and the square root of 2 times 3 is 6. Okay? You can also take the extra step and say, okay, well I know 2 times 2 is 4. That's fine too. Over here, if I do square root of 4 times the square root of 9 times the square root of 2 times 3, I have the same thing going on where square root of 4 is 2 times the square root of 9 is 3 times, and since these are not perfect squares, I'm just going to multiply them. And I need to simplify this. 2 times 3 is 6. Square root's of 6. So that's your answer, that the square root of 216 simplifies down to 6 square roots of 6. 210, let's see if we can, we'll prime factorize that as well, and then see what happens. So I know that this is 10 times 21, and I know that 10 is 5 and 2, and I know that 21 is 3 and 7. So if I write those under the radical, 2 times 3 times 5 times 7, and I just put them in numerical order, just because that made sense to me. And I look for pairs so that I can square root the pairs to bring one of those factors out. And there's nothing in here, right? There are no pairs. These are all prime numbers. There are factors. There's nothing that makes a perfect square. So square root of 210 is simplified form. Okay, so that's how you can check to see if it's simplified or not. Okay, so here's an application. So instead of walking 200 yards from point A to point B, okay, so instead of going around the block on the sidewalk, we're going to take the shortcut across the field from A to B. How long is the shortcut? Well, this is a right triangle, and I know that if I take 100 and square it, and I add the other leg and square it, I get the hypotenuse squared, and I'm just going to label that as C. So 100 squared is 100 times 100 plus 100 squared is 100 times 100, and that's going to equal C squared. This number then I have to add together, right? So I get 20,000 equals C squared. Now to solve this side, I need to square root both sides. And a square root of C squared, that's C times C, so I know that that's just C. And over here now I have to simplify that. Okay, so I need to use prime factorization and see what I can come up with. Well, I know that it would be 100 times 200. And 100 is a perfect square, so I'm going to leave that. And this would be 100 times 2. Okay? So 100, so this is going to be the square root of 100 times 100 times 2, which is the same thing as the square root of 100 times the square root of 100 times the square root of 2. And the square root of 100 is 10 times the square root of 100, which is 10, times the square root of 2. So this is 100 square roots of 2. Now, you might, hopefully, you're looking at this going, wait a minute, if these two side lengths are the same, then I know that I have one of those 45, 45, 90 triangles. So I know that that ratio is in 1, 1, and square root of 2 for side lengths. So if this is 100, this is 100, this would be 100 square roots of 2. So if you could remember that you have rules for when the two sides of a right triangle are the same, you would have been able to find that hypotenuse really fast. Now, you might be tempted to say that this is 100 square roots of 2 yards. Okay, because it's yards. Now, it is, however, when you're talking measurement, don't use the exact. Okay, we want to know how long the shortcut is. If I tell you it's 10 square roots of 2, that doesn't mean anything to you. But we can use those approximations, and as soon as we do, we have to introduce the approximately equal to symbol. No longer is it an equal sign. So I will take 100 times 1.41 to get, move the decimal 2 places, 141 yards. So it's approximately 141 yards. So instead of walking 200 yards, he's walking 141 yards, approximately, across that field. Okay, proving that the shortest distance is always directly between the 2 points. So that's what I have for you for simplifying square roots. I hope you don't find it too difficult. You will need to know these decimal approximations or be able to find them in your notes. Square root of 2 is 141. Square root of 3 is 1.73. Square root of 5 is 2.24, and the square root of 10 is 3.16. And these are approximate values. They're not exactly equal to them. Okay, so that's it for lesson 74. I'll see you in class.